Hello. In this video, I'm going to discuss about energy requirements for various separation methods. You know, separation methods or separation of chemicals requires a significant amount of energy in chemical industry and overall global energy. So there are various separation methods. For example, distillation, uh, drying, evaporation, extraction, absorption, membranes, crystallization. All those separation methods has practical applications. Industry has been using that. One of the methods industry has been using widely is distillation. The question is the energy requirement. So if you have a new problem, which separation method that you would select or choose? So it depends on various criteria. For example, product purity, product yield, and suitability of that methods. So, but energy is one of the major criteria for selection. So distillation, typically what it does, it heats the mixture of the chemicals and one of the mixtures evaporate. So phase change happen, let's say from liquid to vapor phase or gas phase. And then once it comes in the gas phase, a condenser is used. When a condenser is used, again another energy is required to condense the vapor. So double energy is required here, and double times or two times the phase change happens. So this is the distillation is one of the or the highest energy required separation methods. And then the drying also, it's most of the solids are wet in chemicals industries, so those needs to be dried. Those drying process also requires phase change, means the liquid needs to be changed in gas phase, and then it gets separated from the solid. But solid itself, the whole thing needs to be heated up. So as a result, it is the next highest energy required separation method, followed by then the evaporation. Evaporation also requires higher energy because although condensation doesn't happen, one of the component needs to be evaporated. So heat is required to change the phase from liquid to the gas phase. But condensation is not required. That's why evaporation is a lower energy compared to distillation. Another method is extraction. The extraction, it could be solvent extraction, it could be liquid extraction. Extraction means that typically we see the two color, one is red, another or pink, red, another is blue. So these are orange and blue. So one phase is aqueous, another is mostly organic. So when these two phase brings together, one of the molecule transfer, let's say from aqueous to the organic, and when these two phases are mixed together, it's called mixer settler. These two are bringing together in a very close contact and molecular level using a mixer settler mechanical device. So as a result, it also requires huge amount of energy, but it is lower than thermal processes such as distillation, drying, evaporation. After extraction, the next one is adsorption. So adsorption, typically a certain molecule is separated from a mixture. Mostly for dilute sources, adsorption is more suitable. So a certain sorbent is or adsorbent or sorbent is used to adsorb one of the constituent of a mixture. Once it is adsorbed, then it needs to be separated, or solve, or the adsorbent needs to be regenerated. So eventually it also requires huge amount of energy because most of the desorption process, it uses again heat or some acid, some other stuff. So as a result, it also requires some energy. And then absorption also requires energy. The typical method of absorption is, let's say, if you have a mixture of gas to like carbon dioxide and nitrogen, some solvents such as, let's say, deep eutectic solvent, it can selectively absorb CO2, but it doesn't absorb the nitrogen. So in this absorption process that or amine, for example, it can absorb CO2 from nitrogen selectively. So in this solvent, so this absorption also requires energy either in terms of pressure or energy, thermal energy. For example, if it is physical absorption under high pressure, it absorbs the desired gas or target gas. So this pressure is one type of energy. But if it is chemical absorption, the solvent reacts with the gas. Once it reacts with the gas, then it needs to be regenerated. So the typically regeneration is performed by heating the solvent. Again, when you heat the solvent, it requires energy. So absorption also requires energy. And then the membrane. So membrane is one of the most energy efficient method. So in typically membrane separation, what happens, there is a barrier, and this barrier allows certain molecule to pass through the membrane, whereas it rejects the other molecule. So most of the these membrane separation could be performed by pressure, such as reverse osmosis, it requires pressure, or temperature swing, or pH swing. Various driving force could play a role, or concentration gradient chemical processes. But overall, it is one of the least energy required separation processes. And then the least energy required is crystallization. So it's pretty beautiful that in crystallization, typically if you have a mixture of solution where you want to separate one from another, you introduce some crystallizing agent. When you introduce some crystallizing agent, the desired molecule get out of the solution by crystallization. So it doesn't essentially require any pressure or the temperature. So crystallization is one of the least energy required separation methods. Again, all those separation methods has industrial application depending on particular applications, environment, feed constituent elements, their concentration, composition. But if you consider energy, definitely these shows the trend which method is more energy efficient than others. I hope this video helps. Thank you for watching the video.